Hello everyone. So today we're going to work with converting between radians and degrees. We only really work with degrees, and radians are a big measure in mathematics, especially in trigonometry. So I want you guys to see what that looks like. So let me get this presented and we can get through. This should be a pretty quick video today. So we should be good to go. Hopefully it's sharing. Yep, it is. All right. So again, you can use whatever calculator you like. You can use the calculator still from Monday. That might help you. But we're going to go through this. Degrees. Degrees measure angles by how far something is tilted. Now, radians actually are measuring angles by distance, traveled in arc length. So 2 pi is the distance around a circle. And that's why when you start talking about circumference and everything, it has something to do with 2 and pi, or area has something to do with pi. It's because it's about the distance around, or the arc length of a circle. So the radian is distance traveled divided by radius. Degrees, here we have a little just picture to help out, show observer's point of view, whereas the radians show the mover's point of view. So that's the difference between them. To go from degrees to radians. Now, 360 degrees is a full rotation around. But when we start talking about going from degrees to radians, we're using 2 pi as the full circle around. Now, 360 divided by 2 is 180. So we're going to use 180 and pi whenever we do this. The top of the multiplier is the unit you're converting to. So since I'm converting to radians, the top of the multiplier is going to be pi. And then the bottom is going to be the degrees, because that's what I'm trying to get rid of. So pi over 180 is what I'm going to multiply by. And then radians to degrees, I'm going to degrees, so the 180 goes in the numerator and the pi goes in the denominator. Now, if you ever forget what to multiply by, remember 2 pi and 360, and you can always use those as well. Radians must always be in pi form. Degrees must always be in decimal form. Now, there is going to be a later one where I show that is a little bit different, but you're always going to keep this. You're never going to really use pi. You're just going to keep it as it is. And then for degrees, it's always going to be in your decimal form. All right, so I have degrees here. To convert from degrees to radians, I'm going to multiply by pi over 180. So we're going to take 90 multiplied by pi over 180. That gives you 90 pi over 180. Re-reduce 90 over 180. I know what that is. If for some reason you don't know what that is, and that's totally fine, you're going to do 90 divided by 180 in your calculator, and then press math, enter, enter to get it into a fraction. And it's 1/2. So that's also known as pi over 2. And then we're going to write radians after. So we know that it's radians. Just like we do a degree mark, here we're going to write radians. Okay, for the next one, 7 pi over 6 radians, 2 degrees. So we're going to take 7 pi over 6 and multiply it by 180 over pi. Now something cool happens here. The pi's cancel out. So we have 7 times 180, which is 1260 over 6. Put that in your calculator, and you get 210 degrees. And that's the really cool thing about this, is generally the pi's are going to cancel out when necessary going to degrees, so it's going to make it a lot easier. Okay, we're going to go from 200 degrees to radians. So we're going to multiply by pi over 180. And we get 200 pi over 180. And when you reduce that, if you do in your calculator, remember do 200 over 180 and then press math, enter, enter to get the fraction. You get 10 pi over 9 radians. Okay, if this is something you feel really adept at, just keep going. You can always pause the video and check your answers at the end. For the next one, we're going to go to degrees. So it's 5 pi over 4 times 180 over pi. Now, I know sometimes you might get this mixed up, but remember, if you have a pi in the numerator, you need to have a pi in the denominator, and that should help out. The pi's cancel out. 5 times 180 should be 900 divided by 4. and 900 divided by 4 is 225 degrees. Okay. Next one, we have 900 or negative 150 times, we're getting it to radians, pi over 180. So just like this, we can have negatives, so that might happen. That's going to equal negative 150 pi over 180, and this is going to reduce to negative 5 pi over 6. I'm going to double check that one in my calculator. Even if I can do it in my head, I generally try and double check just to be sure, and it is negative 5/6. And we need to put radians after that. Okay, for this next one, now this one's a little bit different because it doesn't have a pi in the radians. So we're just going to make sure that we still put it, if it's in degrees, we have to put it in as a decimal. So we're going to do 5 times 180 over pi, because we are going to degrees, so it's 180 over pi. 5 times 180 is 900. I just did that one. Divided by pi. So now we're going to do this in our calculators. We're going to do 900 divided by, and actually use pi. It's right above your division one. You have to press second first, but actually use pi. Don't use 3.14. And we get 286.5. We're going to round to the nearest tenth. So 286.5 degrees. Okay. Next one, 540 times pi over 180, because I'm going to radians. Pi is in the numerator. And I get 540 pi over 180. 540 divided by 180 should be 3, but I'm going to double check it. And it is 3, so this is just 3 pi. And the last one, we have negative 7 pi over 8 times 180 over pi, because I'm going to degrees. The 180 is in the numerator. The pi's cancel out. And I get negative 7 times 180 is negative 1260 over 8. And I get negative 157.5 degrees. Oops, one thing I forgot, we should have radians after the 3 pi. I mean, radians is implied when you have a pi in there. So if you don't always remember to write it, it's okay. Just if we were trying to be technically correct, that's what you need to write. So that's how you convert from radians to degrees. Now we're going to just look at some of the graphs we did yesterday. We're going to do the same thing, finding our reference angles and everything, but we're going to do them in radians so you can see what this looks like. I'm going to do a little bit of notes on this first one. So this would be 0 pi. This is going to be pi over 2, because a 180 is just a 1 pi, which means this is 3 pi over 2, and this is 2 pi. Now, if it's negative, we're going to go back the other way, but just so we can see what that looks like. Okay, and to find each coterminal angle between 0 and 2 pi, so we are going to find a reference angle. Instead of adding or subtracting 360, like I said yesterday, we're going to use the radian equivalent of 2 pi. So since this is over 8, 2 pi here is going to be equivalent to 16 pi over 8. The 16 divided by 8 is 2. So I'm going to take negative 7 pi over 8, and I'm going to add 16 pi over 8, because this is negative and I need to get to be positive. And negative 7 plus 16 is 9 pi over 8. So that's your reference angle. It's also a coterminal angle. It's referenced because it's positive between 0 and 2 pi. Now this is how we do radians. You might be able to infer this, and that is perfectly fine. Some people might not be able to, so I'm going to show you a couple different ways. So it's negative. So negative 7/8 is going to, we're going to start here with our initial side, and to find our terminal, we're going to go down. Now, negative 7/8 is going to be greater, or well, less than, but it's a bigger absolute value than negative 1/2. It's actually, because 7/8 is closer to 1 whole or to pi, it's going to be close to here. So this is going to end somewhere about here. It's not going to be exact, and that's okay. And since it's negative, we went down and around. Another way you can look at that is if I do negative 7 divided by 8 in here, I get negative 0.875, which is greater than 0 or less than, but the absolute value is greater than 0, it's greater than 0.5, and it's closer to 1 than it is to 0.5. So that's where I knew how to go. Okay, for the next one. The next one is also negative, pi over 6 radians, and this is a special one. We're going to get into that tomorrow. So let's put our initial side down. Now, if this is 0 and this is 0.5, I know that 1/6 is between 0 and 1/2, and it's actually closer to 0 than it is to 1/2. Again, if we want to put that into our calculators, make sure I put my swoosh marks. -1 divided by 6 is -1.7, -0.17, which is closer to 0 than it is 0.5. So that's how we're going to remember that. So now we need to find the coterminal angle or the reference angle. So 2 pi in this case, because we're over 6, is going to be 12 pi over 6 because it has to have the same denominator. So we have negative pi over 6 plus 12 pi over 6. -1 plus 12 is 11. And then we have pi over 6. So that is my reference angle here. Okay, 2 more. If this is something you really understand, you guys are more than welcome to pause this, try it yourself. So we're going to 4 pi over 3. Let's do the reference angle for this real quick. 2 pi here is going to equal 6 pi over 3 because 6 divided by 3 is 2. So -4 pi over 3 plus 6 pi over 3 is going to give me 2 pi over 3. Let's put our initial side down. Remember, the initial side is always in the same place no matter what. And -4/3, the absolute value of that is greater than 0. It's greater than 0.5. It's greater than 1. Because 4/3 is a improper fraction. It's greater than 1, which means it's a little bit more than that. It's about here. And I can do that in my calculator. -4 divided by 3 is -1.33. So maybe it should have been even a little bit closer to 1.5, but it's greater than 1. It's not quite at 1.5. So this should be a little bit closer to 1.5. It's okay. As long as you have it in the right quadrant, you're usually okay. And it's negative, so we're going down and around. Okay, last one. Just looking at this, I know 3/4 is less than 1, so it's going to be somewhere in here because it's greater than 1/2, but less than 1. And it's actually right between 1/2 and 1. So we have this, and right here, greater than 1/2, less than 1, and it's negative, so that's why it's that way. Put this in to find my coterminal. We are going to do 2 pi here is going to be equal to 8 pi over 4, and -3 pi over 4 plus 8 pi over 4 is equal to 5 pi over 4. And that makes sense because this is 1 pi plus another 1/4 of a pi. So it's going to be right here. Okay, that's your notes for today. I'm going to be very honest with you guys. Tomorrow notes are very, very extensive, and it is going to be a lot. You guys are more than capable of doing it, but there's a lot of information coming tomorrow. So be ready. If you need to give yourself some more time, I recommend doing maybe even some of it today. I hope you have a wonderful day.